how to find the I1 and I2. And main current, once again, because it is based on the conservation of charge principle, charge is neither created nor destroyed. How much current is entering at the junction A, that same amount of current is leaving from the junction what C. So that means that you see that in this junction, in this branch, how much current is flowing, what is the I2 and what is the I1 you have to evaluate. So here what you have to do it here, you know that main current you know it. So before that you have to apply the KVL law. So KCL law you have applied already. So from this you got an expression 1. Now let us see, you rotate this mesh. The first step is that before analyzing the network, so first you have to see that whether the direction of current in the different branch is mentioned or not. Direction of current is mentioned in the different branch. Now second step is you have to rotate this mesh in the what? Clockwise, anti-clockwise direction. You are rotating this mesh in the anti-clockwise direction. You see that first you consider AB branch. AB branch, you are rotating this mesh in the anti-clockwise direction. Current is also moving in the same direction. If it is the case, what happens that IR product will be negative. So that is, so current, magnitude of current is I1, resistance is what, 2 ohm, that R1 is 2 ohm, that is 2 minus I1 2 minus I1 into 2, since resistance is R1 is 2, so therefore as I written that 2. Now you come for, this is BC branch. So once again you are rotating this mesh in the what? In the anti-clockwise direction. Current is also moving in the same direction. If it is the case, IR product is taken to be once again minus, what is the magnitude of current and resistance? The magnitude of current is I1 itself, is it? Resistance is 2 ohm, is it? Now you come for, this is a closed loop, you don't go for this side, you come for this side. So you see that here you are rotating this mesh in the anti-clockwise direction, but in this branch current is all coming opposite to it. If it is the case, IR product is taken to be what? Positive. So that means that plus, that means that I will show here, plus, what is the magnitude of current? Plus 2I2, which is equal to 0, since there is no cell. This loop do not have any cell, therefore you can write that EMF of this loop is 0. This expression further you can rewrite, that is minus 2I1 plus 2I2 is equal to 0. You see that this minus 2I1 plus minus 2I1, that will become what? Minus 4I1, which is plus 2I2. So this expression can also be rewritten, that is, on taking this term that side, what happened that 2I2 is equal to 4I1. You can say that this is the 2 ones are, 2 twos are. That is, I2 is 2 times of I1. So I2 current, I mean that second branch, in this branch, current is 2 times of I1. That is, let us see, the current is 2 times of I1. So this I1 I2 value got it. Now this I2 value you have to substitute in equation 1, as I said that this is the equation 1. So here I will show you I is equal to, we are already familiar that this is 6 ampere of current is entering at the junction A. So therefore you get 6, that is I2. So that is I1, it is unknown, it is not known to you. So I2 you know it, I2 is equal to 2 times of I1, that is 2 times of I1. So that means that further simplification this will be used to what, this is 2I1 plus I1, this is 3I1. So this is 6. This is 2 za, this is 1 za. So that is I1 is equal to 2 ampere. I1 is equal to 2 ampere. Sorry, I1 is equal to 2 ampere. So further, once again you consider the equation 1. Further you consider equation 1. So in equation 1, you know that main current value is 6 ampere and branch current I1 value just you are evaluated it, that is 2 ampere. That is 6 2 plus I2. So now this bring this term this side, 6 minus 2, which is equal to I2, or you can say that is 4 is equal to I2. So that is 4 I2 is equal to 4 ampere. So you see that one important conclusion you can draw it from this. So in this branch, what happened that the resistance is increases. 2 plus 2, 4. Whenever the resistance is increases, less amount of current is flowing. So therefore, in the second branch, in the first branch, current is only 2 ampere. Whereas in this branch, this branch which contains 2 ohm resistance, is it only 2 ohm resistance? When the resistance is less, current is more. So therefore, this branch has less resistance, more current. This is second branch. The first branch has more resistance, less current. So therefore, we'll get it. So you can verify that whether your result is correct or not. You can check it also. So now you got it I1 and I2. So you substitute that I1 is equal to, you got it is 2 ampere and I2 is 4 ampere. Is it 2 plus 2, 2 plus 4, it is 6. Once again main current is equal to 6. That is 6 minus 6, once again we will get the 0. So like this, whatever that got it result is correct. Left hand side is equal to right hand side. So therefore, this is the final example. From this example, what conclusion you can write? The charge is charge is neither destroyed, or you can say that charge is conserved. Is it? So whatever the amount of current it is entering at the junction A, the same amount of current is leaving from the junction port C. So therefore, that is once again main current is equal to 6 ampere. So another conclusion you can draw, right? In this, see, this is not a junction, bear in mind. Just you are bend the wire in this fashion. So most of the students, they will get confused. See, this is not, you cannot treat it as a junction. Okay.